Hello everyone, welcome to Code Upwards, where we break down algorithms, data structures and LeetCode problems in the simplest, most engaging way possible. Today we are solving LeetCode 128, longest consecutive sequence, a problem that teaches us powerful set approach for finding sequences efficiently in O of n time. So first, let's give it a read. Given an unsorted array of integers, called nums, return the length of the longest consecutive element sequence. You must write an algorithm that runs in O of n time. Okay, let's try to understand the problem here. So, for an example array nums, that would look like 100, 4, 200, 1, 3, 2. The result is 4. And why is that so? The longest consecutive element sequence is 1, 2, 3, 4. So, if you try to understand what a longest consecutive element sequence means, it's a list of elements that look like we are counting up. So each element in the sequence is followed by the element that you get by adding 1 to the current element. So we have 1, we add 1, we get 2, we add 1, we get 3, we add 1, we get 4. And now we are looking for the longest possible sequence that you can form out of these 6 elements. And here it would be 1, 2, 3, 4. So the length of the sequence is 4, so we return 4. Now, thinking about a first brute force solution would be, okay, in a consecutive sequence, the numbers are sorted ascendantly, so we could just take this array and sort it. So we would have 1, 2, 3, 4, 100, 200. Sorry. And then, so that would be our sorted list. And then we can start at the beginning, start with the 1, and measure the length of the current sequence that starts with 1. So we would go to the 2, we could see, 2 is the consecutive number of 1, so we would be at a length of 2. Then we go to the next number, that's the 3, that's the consecutive number of 2, so we're at a length of 3. Then we go to the 4, consecutive number of 3, so we're at length 4. And then we go to 100. 100 is not the consecutive number of 4, so our sequence is done. This is our first sequence. It has length 4. Then we would be at 100 and would start our next sequence. 100, go to the next number, is 200, but 200 is not the consecutive number of 100, so our sequence would be done. And do the same here. 200, we're at the end of the list, so this sequence is also only of length 1. And then we have our 3 sequences, and this one is the longest, so we return length 4. The problem with this approach is that we need to sort the whole array, and sorting takes n log n time. So that's not a viable option here, because we are required to do it in O of n time. So how can we solve this more efficiently? Let me erase this. Okay. What does a sequence look like? A sequence has a start. In this case, it would be 1. And for the 1 to be the start, there should be no number in here that is exactly our start minus 1. Let's say we would have a 0 in this list, then 1 would not be the start of our sequence. Then 0 would be the start of our sequence. So we would never start a sequence with a number where we have this number minus 1 in our list. So we are looking for a number that is the first in the sequence, and then we will increase this number by 1 to see if the next element in the sequence is there. And we'll do this as long until we are out of the sequence, so until we do not find the next consecutive number. In this case, that would be the 5. And by saving all our numbers here in a structure that allows us to quickly look up numbers, namely a set, we can do this very efficiently. So we take all our numbers and we write them into a set. Now they are unordered, so the difference between a set and a list is that here we have an order and here we don't. So let's assume all our numbers are now in here. We can go through our array and check if we can start a new sequence with this number. So we take the 100, we subtract 1, then we have 99. If the 99 would be in the set, we would not start our sequence here. So let's check. Oh, the 99 is not in the set. So we can start our sequence with our 100. So we start in the sequence. The sequence has length 1, because we only have 100 yet. And then we check for the next element in the sequence. So we add 1 to 100, we have 101, and we check if that number is there. No, it's not. So this sequence has length 1. Now we go to the 4. Can the 4 be the start of the sequence? We check if the 3 is in the set. Oh, the 3 is in the set. So 4 cannot be the start of the sequence. So we will go on. We are to 200. Same as for the 100. We don't find the 199, so 200 can be the start. So we start a new sequence with length 1. But we also don't find the 201. So the sequence is done. Now we are to 1. We look for the 0. 0 is not here, so 1 can be the start of a new sequence. And then we look for the 2. I see the 2 is there. Okay, so we continue our sequence. We are now at length 2. Now we look for the 3. The 3 is also there. That's nice. So we go on. So our sequence grows. And now we look for the 4. 4 is also there. Our sequence already has length 4. Now we look for the 5. 5 is not there. So our sequence is done. And we were at the 1. Now we go to the 3. 3 we are not starting a new sequence because the 2 is there. 2 we are not starting a new sequence because the 1 is there. And we are at the end. So we found our same sequences. And now we check which is the longest one. This is the longest one. Now, so we went through the list one time and we did these lookups. Every lookup is constant time. That's the benefit of a set. Now the question is, why is the runtime O of n? The runtime is O of n because each number is at most part of one sequence. Every number is part of exactly one sequence. Because how could it be part of two sequences? It could not, because then the sequences would be overlapping and then we could just form one big sequence out of it. So every number is part of one sequence. Being part of a sequence means that we will look for the next number. So we will do one lookup. And when we iterate through the list, we will also do one additional lookup for the previous number to check if the current number is the start. So for every number in the list, we'll make 2 lookups. Once for the previous one and once for the consecutive one. So we have 2 n lookups, and that means that we are an O of n one time. I hope that was clear. Let's go to the code. First of all, we want to create a set that allows us to efficiently look up if a number is part of nums or not. Let's call this num set. And in Python we can do that by simply writing set of nums. This will convert nums, the nums list, into a set. And then we want to keep track of the longest consecutive sequence we have seen so far. So let's create another variable, call it longest, and initialize it with 0, because we have not seen any sequence yet. Now we want to iterate through the numbers that we have. let's say for num in num, and we could iterate through nums, so through the list of numbers. But the nice thing about sets is that all the elements in here are unique. So if we would have a number that's part of nums multiple times, that would not make the consecutive sequences any bigger, but it would increase the runtime here because we would iterate through it multiple times. So we can simply iterate through numset, and then we get all the unique occurrences of these values. And then what do we want to do? We want to check if the current number is the start of a new sequence. And it's the start of a new sequence if num minus 1 is not part of numset. So we'll say if num minus 1 not in numset, then we know we're at the start of a new sequence. So we initialize our new sequence length. We have a new sequence with length 1 currently, because only num is in it. And we start looking for the consecutive numbers. And as long as we find consecutive numbers, we will keep increasing length. So we'll say while, because we need a loop here, while num plus length in the set of numbers we have, we will increase length. So in the beginning, we will look for num plus 1. If we find num plus 1 in numset, we will increase length by 1. So we'll then look for num plus 2. And we will go on until here, let's say num plus 5 is not part of the set anymore. Then we know that num plus 1, num plus 2, num plus 3, num plus 4 are part and are forming a sequence of length 5. So when we exit the loop, we know we have found the end of our sequence. We now want to make sure that we keep track of the longest sequence. So we'll say longest equals to maximum of longest and the length that we found, so the length of the current sequence. After we are done, so after we have gone through all the numbers, and I mean we only do this for the actual starts of the sequence, we can then return longest. Let's run the test cases. That looks good. And let's submit the code. And it looks fantastic. And that's how you solve longest consecutive sequence in O of n time. Thank you for watching, and I'll see you in the next one. Keep coding upwards.